Did you know that there is a secret unlock for the FRQs in the AP Physics exam? I'm not even joking. Of course, you need to know physics and all of physics to do well on the FRQs. There is a secret code behind how they put together the FRQ questions. There is going to be 4 FRQ questions, and they even have names, the 4 kinds of 4 names. If you understand this, it will greatly increase your score for the FRQ section of the AP Physics exam. The first kind of question is called mathematical routines. Here, what they're wanting is for you to use mathematics to derive an expression. Derive an expression for the speed Vf of the block cart system after time t equals t2 in terms of mc, vc, and physical constants as appropriate. So the key question in this mathematical routines is to derive an expression. There's actually some other parts to it, and there's a journey you'll go through every time. I'll delve deeper into this journey of question 1, mathematical routines, in the video. You can find the link for that below. The second kind of FRQ is called translation between representations. What's a representation? The idea is that in physics, we'll have some kind of situation, and there's different ways that we can represent this. The most common way we represent things in physics is with diagrams and equations. But there's a number of key representations that you should have studied in your AP Physics course that they'll expect you to be able to produce. These will include a free body diagram, an energy bar chart, and motion diagrams, and various graphs. So each of these kinds of tools or representations is a different lens on what's going on. Let's look at an example. A block of mass m is released from rest at position x is 0 near the top of a ramp. Figure 4 shows an energy bar chart that represents the kinetic energy k of the block and the gravitational potential energy Ug of the block Earth system, and the spring potential energy Us. Draw the shaded bars that represent K, Ug, Us to complete the energy bar charts in figures 2 and 3. But the key idea here is we need to do an energy bar chart, which is one type of representation. Again, there's actually more components to this question, and the full breakdown of that will be in the next video. The third kind of question is called experimental design. Here, they're wanting to see if you understand how physics principles will be worked out in reality with an experiment. And this question has a very clear journey, a path that you will follow every time. And there are 4 steps. The first step is to describe an experiment. So there'll be some topic and you have to talk about what that experiment is. Second, you'll have to describe how to collect data. So you need to be thoughtful about the way that you would organize the data to plot a graph. Third, there'll be some data, and you'll need to plot that data on a graph and find a line of best fit. And fourth, you'll need to calculate a variable. Students are investigating balancing systems using the following setup. Students have a spring scale of negligible mass that is fixed to one end of a uniform stick. So we see a diagram there of the mass and the holes in the spring scale. The students are asked to take measurements that will allow the students to create a linear graph whose slope could be used to determine the mass m0 of the block. Describe an experimental procedure to collect data that would allow students to determine m0. So in part A, you have to describe the right steps to create an experiment. Okay, again, this is an overview. I just want you to understand the 4 kinds of questions. And if you want a deeper dive, I'm going to have a video on each one of them. The 4th kind of question is qualitative, quantitative transitions. Well, what the heck is that? What is qualitative? What is quantitative? So qualitative is where we talk about qualities. And the idea is we're going to use words and descriptions and English rather than equations. Quantitative uses quantities. That is, we're going to use numbers and variables and equations and algebra and math. The first part will have a question and you have to do qualitative analysis. So describe what's going to happen with physics just using words and not using equations. In the second part, B, it will say derive some expression. That's quantitative. That's using the math. And then in the third part, we're going to put them together. So just words, then the math, and then say, do they connect somehow? So that's question number 4. So now you have the keys to the kingdom. You know the secret code of the FRQ questions. I'm going to continue to do one of each of the kinds of FRQs to show you how they work out in more detail. But for you to feel like a master of this topic, you're going to need to do practice questions. I highly recommend you get a resource like the Princeton Review AP Physics Exam Prep Guide, which has many questions, including FRQ questions, for you to practice.